Okay, let's get started. So in this section, we're going to start with 4.2, or in this video, and then we'll also do 4.3. And so 4.2, what did we do last? Oh, the zeros. So in this section, we're going to be graphing the equations like from last section that we were finding the zeros of. So for example, let's say we want to start. Let's start with 14. For all the following, we're just going to be graphing. So graph the following. That's the directions for these problems. And so there's a sequence of steps. So the first one we'll do is g of x is equal to x to the fourth minus 4x cubed plus 3x squared. So in order to graph these, what we want to do is first we want to factor this thing as much as we can. And the first thing we can do is every piece has at least an x squared, so we could take out an x squared. So we can write this as x squared, and then we'll have x squared minus 4x plus 3. And then what we can do is we can factor this a little bit more. So g of x is equal to, we'll have x squared. And then we can factor the x squared minus 4x plus 3 part. That's going to be x minus 3, x minus 1. So we have everything completely factored. So this is what we want to use now for g of x. We don't want to use what's given to us. I'm sorry. Okay. Why is that white screen there? Okay. So now what we want to do is once we factor it, we want to find all of our zeros. I'm sorry, I don't know why this is doing this. Okay, so we have our factored version, so let's find the zeros. So we'll have x squared, x minus 3, x minus 1 is equal to 0. So then we set the pieces equal to 0. We have x squared is 0, x minus 3 is 0, x minus 1 is 0. So this one gives us x equals 0. This one gives us x equals 3. And this one gives us x is equal to 1. And so now the next thing we're going to do is once we find all of our zeros, we want to put these onto a number line. Let's do that. So we have 0, 1, 3. And then what we're going to want to do now is we are going to pick numbers in between all these sections. So here, 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 and here. And we want to plug those numbers back into g of x to see if we get a positive or a negative number. So again, let's rewrite g of x is equal to x squared, x minus 3, x minus 1. I'm going to move that down a little bit. So any number in this section up here on the left, so anything to the left is 0, we could plug in minus 5. Anything in between 0 and 1, we could choose 1/2. Anything in between 1 and 3, we could choose 2. And anything bigger than 3, I don't know, like 5. So what we're going to do is we want to plug these numbers into g of x, but we don't really care about the number value. All we care if it's going to be positive or negative. So when we plug in minus 5, what do we get for g of x? Well, if we plug in minus 5 to this first part right here, minus 5 squared is a positive number. So this is going to be positive. Then we would have minus 5 minus 3, which is a negative number, and minus 5 minus 1, which is a negative number. So if you take a positive, a negative, you multiply them together, you get a positive number. So we're going to put a plus sign over here. Now for 1/2, the first one will be positive. The second one will be negative. And then the third one will also be negative. Negative. So we have a minus sign right here, or a plus sign right here. Since we have, again, a plus sign and a minus, that makes a negative. Oh, sorry, makes a positive. And the next one, 2. So if we have 2 squared, that's going to be positive. Then we have 2 minus 3, which is negative. And then 2 minus 1, which is positive. So this gives us a negative. And the last one, 5. We have a positive, and a positive. So it gives us positive. And so we're going to use this chart to, this number line we have right here. This is what we use to graph. So let's put a graph over here. And on the x-axis, we're going to put all of our zeros. So we had a 0 at 0. Let's put a dot right there. We had one at 1. And we had one at 3. So 0 meaning the graph is 0 at these points. So now we look at the graph. So and we know since the zeros only happen at 0, 3, and 1, the graph can only touch the x-axis at these dots that we have on the x-axis right now. Because say if the graph touched over here, that would mean this point's a 0, but that point's not a 0. The only points that are zeros are 0, 1, and 3. So we look at this chart over here, this number line. We see to the left of 0, it's a plus sign. So plus means we go up, so the graph's going to go up over here. Now in the middle between 0 and 1 is plus. So plus means positive, so that means the graph goes up, but it has to come back down and touch that 0. In between 1 and 3, it's a minus sign. Minus sign means we go down, but we got to come back and touch that next 0. And then to the right of 3, it's plus. So plus means it goes up. So then what we drew is right here. This will be what the graph looks like. And this is always, let's do a couple more problems like this. These are always the steps that we do. So let's do some other problems. Just to kind of, or get the idea in there. Let's do 19. So 19 is h of x is equal to x minus 4, x plus 1, and x minus 2. So it's already factored for us. So the first thing we need to do is find the zeros, which is easy since it already has it factored. It's for x plus 1. So here we're going to see that x is going to be 0, x can be 4, x can be minus 1, and x can be 2. So here's all of our zeros. So just like before, we put these zeros onto a number line. And then we pick points in each of these sections. So the first point we pick, left of minus 1, so let's choose minus 10. In between minus 1 and 0, we could choose minus 1/2. In between 0 and 2, choose 1. In between 2 and 4, we could choose 3. And bigger than 4, we could choose 6. All right, so now we plug all of these points back into h of x to see if it's a positive or a negative number. So we plug in 10. So again, h of x. So we're plugging it into this function. If we plug in minus 10, well, we'd get a minus here, sign here. We get another minus sign here. We would get another minus sign here. And again, another minus sign here. So you do 4 and minuses, multiply them together, that becomes a plus sign. Okay, now for 4. The first one will be positive. Oh, wait, sorry, where am I plugging in 4? I don't know why I'm doing that. Oh, we've got to plug it. The next one we chose was minus 1/2. That's the one we're plugging in. Okay, so the first sign, just plugging that into x, if you plug minus 1/2 in there, we get a minus sign. The next one would also be a minus. Plugging it into the next one would be plus, and plugging it into the last one would give us minus. Sorry, 1 second. Just want to make sure I copied everything down right. Okay, this is good. All right, so then we get 3 minuses all together and a plus sign. That gives us a minus. So we put a minus right here. All right, so the next number we chose was 1. If we plug 1 in, we're going to get plus, minus, then plus, and then minus. And that makes a positive. Next number was 3. So if we plug 3 in, we're going to get plus, minus, plus, plus. So that gives us a minus sign. The last one's 6. They'll all be positive. And that gives us a positive. All right, so we have our table. So we can draw our graph. And we always start with putting the zeros on the graph. So our zeros were -1, also 0. Then we had 2. Then we had 4. Let's move this over a little bit. Okay. So to the left of -1, we have a plus sign. If you look at this graph over here, the number line. So to the left of -1, we have a plus sign. Plus sign means go up. In between -1 and 0, it's minus, so it goes down, then it comes back up. In between 0 and 2, it's positive, so it goes up, then it comes back down and touches 2. And in between 2 and 4 is minus, so minus goes up. And then to the right of 4, it's a plus sign, so it goes up. Okay, and so this will be our graph. How about 26? So 26 is g of x is equal to x minus 2 cubed, cubed x plus 3. So to find our zeros, we're going to get x is equal to 2 and x is equal to -3. So we put those onto a number line. And just pick some numbers over here. To numbers to the left of -3, just, I don't know, -5. In between -3 and 2, we got 0. And bigger than 2, we could choose 10. So if we plug -5, so g of x, actually, we already have it written up here. So, plugging it into g of x, if we plug -5 in right here, we're going to get a minus number cubed, which is a negative number. And if we were going to plug it in right here, we would get another negative number. So that's going to be positive. If we plug in 0, we would get, again, a negative number cubed. So 0 minus 2 is -2. You cube that, you get -8. So the first number is going to be negative. And if we plug in 0 right here to the next one, we get a positive number, 0 plus 3. So this is positive, or sorry, that's negative. Okay, we had a positive, negative, and we plug in 10, we'll get 2 positives, which is positive. So go to our graph, put the zeros on at -3 and 2. So to the left of -3, we were positive. In between -3 and 2, it was negative. And bigger than 2 is positive. So it looks something like this. How about 30 or yeah, sure, 36. So 36 is h of x is equal to x to the 5th minus 5x cubed plus 4x. Okay, so we got to find the zeros. First thing we do, we could just factor out an x. So h of x is equal to x. X to the 4th minus 5x squared plus 4. All right, but we still need to keep factoring. So remember, we had the technique to factor the ones that look like this. We needed to do that like u substitution type thing. So for this one, we're going to let u equal x squared. And that means u squared is equal to x to the 4th. So we're going to rewrite this. So we'll have x, and then this is going to be u squared minus 5u plus 4. And then we could factor that. So that's going to be u minus 4, u minus 1. And then we plug in our u's. So this is going to be x. U is x squared. So we're going to, sorry, I don't know why it keeps doing this. Okay. Then we'll have x squared minus 4, x squared minus 1. And then we can keep factoring. So this is going to be x minus 2, x plus 2. This will be x minus 1, x plus 1. So this right here is how we could have h of x completely factored. So now we got to find the zeros. So our zeros here, we're going to have x is equal to 0, x is equal to 2, x is equal to minus 2, x is equal to 1, x is equal to minus 1. So those are all the zeros for h of x. So we put those onto a number line. Okay, so a number in each of these sections, put minus 10 over here. You can do minus 3 halves, minus 1 half, positive 1 half, 3 halves, and 10. Okay, so we have all these numbers. Now we've got to plug those into h of x. So if we plug in minus 10, so looking at this box up here, the first number is x. So if we plug in minus 10, we'll get a minus. Then we have minus 10 minus 2. That's minus. Minus 10 plus 2. That's a minus sign. Minus 10 minus 1. That's minus. And then minus 10 plus 1. That's minus. So 5 minuses, that gives us a minus. Okay, now minus 3 halves. The first one will be minus. And then we have minus 3 halves minus 2. That's minus. Minus 3 halves plus 2. That's positive. Minus 3 halves minus 1 is minus. And minus 3 halves plus 1 is minus. So this gives us a positive. The next one was minus 1 half. So the first one's minus. Then we have minus 1 half minus 2. That's minus. Minus 1 half plus 2 is positive. Minus 1 half minus 1 is minus. Minus 1 half plus 1 is positive. So this gives us a negative. And positive 1 half, we have positive. 1 half minus 2 is negative. 1 half plus 2 is positive. 1 half minus 1 is negative. And 1 half plus 1 is positive. So this will give us a positive number. Then we have 3 halves. So first one's positive, then we'll have a negative, then a positive, then a positive, and then a positive. So this gives us a negative. The last one, 10, everything will be positive. So it gives us a positive. Okay, so we have our number line. Let's draw our graph. So what are our zeros? Our zeros were minus 2, minus 1, then we had 0, and then 1 and 2. Okay, so to the left of minus 2, we have, if we look up on our number line, to the left of minus 2, we have a minus sign, so it goes down. In between minus 2 and 3 is positive, so it goes up and it comes back down. In between minus 1 and 0 is minus, so it does something like that. In between 0 and 1 is positive, so it does that. And in between 1 and 2 is negative. And then it is positive to the right of 2. All right, so that would be the graph for h of x. All right. Okay, so only one more type of question from this section. So we have to talk about something called the intermediate value theorem. So basically what this just tells us is if, suppose f of a is bigger than 0 and f of b is less than 0, then there exists a number c such that f of a, or sorry, a is less than c is less than b, so c is in between the two, and f of c is equal to 0. So in a picture, what does that mean is so, suppose we have like, let's say here's A, here's B. We said f of A is bigger than 0. We said f of B is less than 0. So maybe it does something like this. Here's f of A, goes down to f of B or down here. So what this picture sort of means is that, well, if there's a number bigger than 0 and then there's a number less than 0, then the graph has to pass through 0 at one point to get to the other point. So then this piece right here, this would be the C value. C. So there's a C value in between the A and B, because if one number is bigger than 0, one number is less than 0, you got to pass through 0 to get to the one that's positive to go to the one that's negative. So that's basically what the theorem says. And so for these next questions, so using the intermediate value theorem, determine if there is a 0 between the given points. Okay, so like for example, number, I don't know, 41. So number 41, we have f of x is equal to 3x squared minus 2x minus 11. And then the given points, a is equal to minus 3, and b is equal to minus 2. So what we got to do, let's just plug in these 2 points and see if one of them is negative or one of them is positive, and then we'll know if there's a 0 in between the two. So f of minus 3, this is equal to 3 times minus 3 squared minus 2 times minus 3 minus 11. So this is going to be 3 times 9 plus 6 minus 11. So 27 plus 6 minus 11. So that's going to be 33 minus 11, just 22. All right, and now f of minus 2. We have 3 times minus 2 squared minus 2 times minus 2 minus 11. This is going to be 3 times 4 plus 4 minus 11. So 12 plus 4 minus 11. So 16 minus 11, which is 5. So in this situation, notice how both numbers are positive. So when we have both numbers being positive or both numbers being negative, then it's undetermined whether there's a 0 in between these two numbers. So we could say, so since f of minus 3 and f of minus 2 are both the same sign, in this situation, they're positive. We do not know whether there is a 0 between minus 3 and 2, or minus 2 and minus 3. There may be or there may not be, but we need to know for sure, we need to one have positive, one be positive, and one be negative. So let's try, hopefully we can find one that'll work. Maybe 39 is, let's do this one. So 39 says f of x is equal to x cubed plus 3x squared minus 9x minus 13, and a is minus 5, and b is minus 4. Okay, so what's f of minus 5? well, we have minus 5 cubed plus 3 times minus 5 squared minus 9 times minus 5 minus 13. So minus 125. And so that's going to be 3 times 25, which is 75. And that's going to be plus 45. And that's going to be minus 13. So this is going to equal, so we have minus 125. What are those middle two numbers? 120. Okay, minus 13. So this is going to be minus 5 minus 13, which is minus 18. All right, see what happens when we plug in minus 4. So we have minus 4 cubed plus 3 times minus 4 squared minus 9 times minus 4 minus 13. So what's 4 cubed? Okay, we have minus 64. And then here we have 3 times 16. So 3 times 16. So plus 48. And then 9 times 4 is 36. So plus 36. And then minus 13. So let's see, we got 36 plus 48 is 84. So this is going to be minus 64 plus 84 minus 13. Okay, so I'm going to do minus 13 minus 64. Okay, and this is going to equal 7. So we do know, so since f of minus 5, which is equal to minus 18, is less than 0, and f of minus 4, which is equal to 7, is bigger than 0, then the intermediate value theorem, so intermediate value theorem, says there is a point C such that minus 5 is less than C is less than minus 4, and f of C is equal to 0. Okay, that's good from that section. Mainly the graphing is the only important part. All right, so let's finish up with section 4.3. Okay, so the first thing we're going to talk about is, so how do we do long division with functions now, not just like numbers, how we kind of did, previously maybe in, I guess, elementary school. So like, for example, with number 1, what we want to do is, so we're given f of x is equal to x to the 4th minus 6x to the 3. I guess before we do that, let's just kind of like give a brief introduction to this. So what we're going to do in this section now is we'll have something, maybe like x minus a, and want to, divide some polynomial inside here. So maybe like a n x to the n, a1 x to the 1 plus a naught. So we want to somehow find a way to do division with these polynomials and stuff. So what we have here, these things are going to be referred to, each of these pieces will be referred to as something. Sorry, I need to look that up. I believe this is called d of x. That was a bad bracket. What we end up getting up here is called the quotient, so q of x. What do they call the inside? P of x is this inside piece. And then we're going to do some work. Basically, we'll end up down here. And whatever we get down here, this is going to be called the remainder, r of x. So if we say q of x, maybe we can write these out. So d of x, this is called the divisor, but we'll usually just refer to it as d of x. Q of x is the quotient, and r of x is the remainder. And so there's an important equation that relates these two things together. Oh, where's that at? So P of x is going to be equal to D of x times Q of x plus R of x. So this is important. Why this is important is because it sort of gives us a way to factor P of x. So, factoring usually means we take something and we, write it in more simple terms or whatever. Maybe not necessarily simple, but we just sort of write it with more terms. So here we could think of it like we're factoring P of x into this right-hand side. And so the way we can sort of factor it now is just by using this division stuff. So let's go through the steps. How can we divide polynomials, and how can we use this equation? So for example, let's start with number one. So we're given f of x is equal to x to the fourth minus 6x cubed plus x squared plus 24x minus 20. And this technique up here, when we write it like this is called long division. And we'll do something called synthetic division in a second. All right, did I copy everything right? Yep. All right, so we want to do long division with a couple of things. And this problem is telling you to determine whether the following are factors. Determine whether the following are factors. And a factor means that the remainder is going to be 0. So a factor, this just tells us that R of x is going to be 0. So for the first one we want to do it with is with x plus 1. So in order to know if x plus 1 is a factor, we need to do the division with x plus 1 and see if our remainder is 0. All right, so let's start with this. So we write x plus 1, and then we put our polynomial in here, x to the fourth minus 6x cubed plus x squared plus 24x minus 20. So the steps to do division with these polynomials now is, well, we look at what's the divisor, what's on the outside. And all we care about is the first term. In this situation, that first term is an x. And then we want to know, what do we need? Sorry, I don't know why this keeps happening. We want to know, what do we have to do to x? So what do we have to multiply it by in order to get x to the fourth? And that's going to be x to the 3. And then what we do is we put that x to the 3 right above it. So again, x to the 3 times x is x to the fourth, and which is that piece right there. And that's why we're putting that up there. So then what we do is we take our x to the 3, and we're going to multiply it by x, and we're going to multiply it by 1, and put those two numbers right here. Okay, so x to the 3 times x, that's x to the fourth. X to the 3 times x, x to the 3 times 1, that's x to the 3. Then we put a minus sign, and then we're going to subtract these two numbers. So x to the 4 minus x to the 4 is 0, and minus 6x to the 3 minus x to the 3 is minus 7x to the 3. And then we repeat those same steps again. So what do we need to multiply by x to turn it into minus 7x to the 3? And that's going to be minus 7x to the 2. So we do that multiplication, and then we bring down our next piece. So we bring down the next piece plus x squared. Okay, so now we multiply this minus 7x to the 3 back to these guys, and then do that subtraction thing again. So minus 7x to the 3 times x is minus 7x to the 3. Minus 7x to the 2 times 1 is minus 7x to the 2. Subtract. So the first bit's 0, and then we get x to the 2 minus a negative 7x to the 2, so 8x to the 2. Then bring down our next piece. And then do that same step again. So what do we got to do? X multiply by to turn into 8x squared. So that's going to be just 8x. And then we do the multiplication. So 8x times x is 8x squared. 8x times 1 is 8x. Subtract. So that's going to be 16x. Bring down the minus 20. All right, so what do we got to multiply x to turn it into 16x? That's just going to be 16. So what we have is 16x. plus 16. Subtract these. So then we get 0 and then minus 20 minus the 16, so minus 36. So in this problem, we see that our d of x is equal to x plus 1. P of x is equal to x to the 4th minus 6x cubed plus x squared plus 24x minus 20. The q of x, which is the piece on top, is x to the 3, 7x squared, 8x plus 16. And our remainder is going to be minus 36. So we know that x plus 1 is not a factor because the remainder is not equal to 0. Our remainder is equal to minus 36 here. So in this situation, x plus 1 is not a factor. Okay, now let's do part B together. So now it's asking us, what about x plus 2? So let's do division with x plus 2 now. So the p of x is again, so x to the 4 minus x cubed plus x squared, 24x minus 20. Okay, so now same thing. So what do we have to do? Multiply by x to get x to the 4th. And that's going to be x cubed, so we put an x cubed here. Then we do that multiplication step, so x cubed times x, that's x to the 4th. X cubed times 2, that's 2x cubed. Subtract. So x to the 4th minus x to the 4th is 0. Minus 6x cubed minus 2x cubed is minus 8x cubed. And then bring down the next piece. Okay, now what do we do? X to multiply by to turn into minus 8x to the 3. And that is going to be minus 8x squared. So we have minus 8x cubed minus 16x squared. We're subtracting these. And what do we get? So 0, and then x squared minus a negative 16x squared, that's 17x squared. And we'll bring down the next one. Okay, so x has to multiply by what to turn into 17x squared? That's going to be 17x. So we get 17x squared, and then 17x times 2 is 34x. Subtract these. Then we get minus 10x left over, bring down the minus 20. So then what do we need to multiply by x to turn into minus 10x? That's just going to be minus 10. Okay, so minus 10 times x is minus 10x. Minus 10 times 2 is minus 20. When we subtract these, and then we get 0. So in this problem, our d of x is x plus 2. Our p of x, which is same as the previous problem, x to the 4. Then we have q of x is the thing on the top. And then our remainder is 0. So in this problem, x plus 2 is a factor. Because the remainder is 0. And lastly, so remember in the previous, in the beginning of the section, we said that there's this equation that p of x is d of x, q of x, plus r of x. So what we can say now is, well, what's p of x? P of x was that big piece. Let's rewrite that again. So this means that x to the 4, 6x cubed, x squared, 24x minus 20 is equal to d of x. D of x is x plus 2 times q of x. Q of x is x to the 3, 8x squared, plus 17x minus 10. And then plus the remainder, but the remainder is 0. So really what we just did here is we used division to factor this piece into this times this. So this is just sort of like an extra piece of why we're doing this division. So now we can factor things that are more complicated by using this long division. Okay, let's do let's do number 9. So what we want to do is we're given p of x is equal to x to the 4th, 2x squared plus 3, and d of x is equal to x plus 2. And we want to find r of x and q of x. So I don't know why this keeps happening. So in this problem, basically the same thing as last one. So let's find, all we have to do is just do the division. We're given our p of x, given our d of x, so we can set up our division thing. X plus 2. And then you remember p of x goes inside here. But this problem's a little bit different. So if you look in the last problem, our p of x, well, we have it written right here. Notice how the powers count down. So we have a power of 4, a power of 3, a power of 2, then here's our power of 1, and then nothing. So we need that to always happen. And if it doesn't happen, we need to put these placeholders in. So you see in this problem, it goes power of 4, power of 2, and then it skips the third power and it skips the first power. So what we need to put on the inside is we're going to start with x to the 4th, but then we need a placeholder for an x to the 3. And we have our x squared here, but then we also need a placeholder for our x, and then plus 3. So if it ever skips, like how it does here, how it goes from 4 down to 2, we need to put these placeholders in, like how we just put here with zeros. But once we do that, then we just do the division steps like before, just the same way. So what do we need to multiply by x to turn into x to the 4th? Well, that's going to be x to the 3. Then we do x to the 3 times x, which is x to the 4th, x to the 3 times 2, which is 2x to the 3, and then do subtraction. So x to the 4th minus x to the 4th is 0, and 0 minus 2x cubed is going to be minus 2x cubed. Then bring down the next one. So what do we have to multiply by x to turn into minus 2x cubed? And that's going to be minus 2x squared. So minus 2x squared times x is minus 2x cubed. And minus 2x squared times 2 is minus 4x squared. Subtract. And now we get 2x squared. Bring down that 0. So x times what is 2x squared? That's just going to be 2x. Okay, do our subtraction. 2x squared minus 2x is 0, and then 0 minus 4 is minus 4x. Bring down the 3. Positive 3. Okay, so x times what is going to be 4x, and that's going to be, or minus 4x, so that's a minus 4. Okay, so minus 4 times x is minus 4x. Minus 4 times 2 is minus 8. We subtract, so this becomes 11. So in this problem, we get that our d of x, well, let's give, so we just wanted to find r of x and q of x. So our r of x is always that number down here. R of x is 11. And q of x is this thing on top. All right. So let's see what are the homework problems. 21, where's 21? Okay, that was 39 and 40. Okay. So that's long division, what we just did. Let's talk about something called synthetic division now. So with synthetic division, let's actually just do the previous example. So let's do that same thing. So we're given that d of x was equal to, in this problem, is x plus 2. And q of x, or sorry, we're looking for q of x. P of x was x to the fourth minus 2x squared plus 3. And so now let's do synthetic division. So what synthetic division is the synthetic division symbol is we write this bracket like this. And we need a little bit more room. So we look at our, sorry, 1 second. We look at whatever our d of x is up here. So the d of x is always going to be, x and then plus some number. In this situation, that number is positive 2. So we take the opposite of that number where we write it right here. So we're going to put a minus 2 up there. The next thing we're going to do is, we look at our p of x, and what's the highest exponent? That's an x to the fourth. So we need a column for an x to the fourth. We need an x to the third column. We need an x squared column. We need an x column, and then just our constant at the very end. And then the numbers we're going to put here are the numbers that are in front of those exponents. So in front of an x to the fourth, we have a 1. And since we don't have an x to the 3, we put a 0. The number in front of x to the 2 is a minus 2. We don't have an x, so we put a 0. And our constant term is 3. Okay, so now the steps for synthetic division is we take our first number, which is 1. And the first thing we do is move it down here, 1. Then what we're going to do is we take this number, multiply it by that, and put it right here. So minus 2 times 1 is just minus 2. And then what we do is we add these two numbers. So 0 plus minus 2 is just minus 2. And then we keep repeating those steps. So minus 2 times minus 2, that's positive 4. We add these two numbers, that gives us 2. And then we repeat those steps again. We have minus 2 times 2, that's minus 4. Add those numbers, you get minus 4. And then one more time, minus 2 times minus 4 is 8. Add those numbers, you get 11. So this last number, we always kind of put it in a little box like that, and that's always going to be our remainder. So our remainder is always the thing in the very end that's going to be 11, which is what we got in the previous problem up here. And then what we do is to find our q of x, these are the coefficients of q of x, and we start with 1 less power than what we have up here. So since that's our x to the 4, then down here, this is going to be an x to the 3. Since this is x to the 3, this is going to be x to the 2. Since this is x to the 2, that's going to be x to the 1. And then since one less than that, that's going to be our new constant. So what our quotient is going to be is, so we have 1 x to the 3, so just x to the 3, minus 2x squared, so it's minus 2x squared, 2 times x, and then just minus 4 is our constant. And if you notice, that's exactly what we got in the previous problem. However, it was much quicker using synthetic division. So up here we had all these steps, but down here we were able to do the problem pretty quickly. Okay, let's do some more synthetic division examples. So how about number 12? So again, we want to find d of x and q of x when, find r of x and q of x when p of x is equal to, or they're writing it a little bit differently. So find q of x and r of x, and so the way they're writing this problem is going to ordinary 12. So we'll have x to the 3, 7x squared, 13x, 3 divided by x minus 2. So when the problem is written it like this way, this piece right here is going to be our p of x, and this piece right here will be our d of x. So in this situation, okay, we are using that division. So now we have an x minus a 2. So since that's a minus 2, we're going to put a positive 2 over here now. If you remember in the previous, whenever that was a plus sign, we put the minus, and whenever that's a minus, we put a plus. So if you look in this last problem, we had x plus 2, so we put a minus 2 here. Now in this one, we have x minus 2, so we put a positive 2 here. It's always the opposite sign. Okay, and so now what's our highest exponent of p of x? Well, that's an x to the 3. So we need to have an x to the 3 column, x2, x1, then our constant. So what's the number for x in front of x to the 3? It's a 1. In front of x squared is a minus 7. In front of x is 13, and our constant is 3. All right, so now let's do the synthetic division step. So we always, whatever the first piece is, which is 1, we write it down here. And then we do 2 times 1, which is 2. Add those numbers, so we get minus 5. Multiply 2 times minus 5. Multiply this and this. It's minus 10. Add those, we get 3. Then we do 2 and 3, which is 6. Add those, and we get 9. Okay, so we started with our first column was x to the 3. So down here, it's going to be x to the 2. It's always 1 less. And this is our remainder at the very end. So in this problem, we get our remainder is 9. And our q of x is going to be, so 1x squared minus 5x, and then plus 3. Okay. Let's do one more together. How about 20? So find q of x and r of x. And we are given, so x to the 5 plus 32 divided by x plus 2. So again, the thing on the left of that division sign, that's going to be p of x, and on the right is going to be r of x, or sorry, d of x. Okay, so here's our synthetic division symbol. So because we have an x plus a 2, we're going to put a minus 2 here. And then our highest exponent is an x to the 5. So we need an x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, and then a constant term. So what's the number in front of x to the 5? That's a 1. We don't see an x to the 4, so we have a 0. We don't see an x to the 3, so we have a 0. We don't see an x to the 2, so 0. We don't see an x to the 1, so 0. And our constant is 32. Okay, so now we just do the synthetic division step. So bring down the first thing, which is a 1. Minus 2 times 1 is minus 2. Then we add them. So 0 plus minus 2 is minus 2. Then minus 2 times minus 2 is 4. Add 0 and 4, we get 4. Minus 2 and 4 is 8. Add those, we get 8. Minus 2 times 8 is minus 16. Add those, we get minus 16. Minus 2 and minus 16 is positive 32. Add those, and we get 64. Oh, hold on, we made a mistake somewhere. We should have got 0 for the remainder. So what did we do wrong here? Oh, let's see the problem. See how we were supposed to do minus 2 times 4, which would have been minus 8, but we put a positive 8 here. That needs to be a minus 8. All right, we got to erase these guys. So up to this point was okay, but we need to do minus 2 times 4 is minus 8. Add those, we get minus 8. Then minus 2 times minus 8 is positive 16. Add those, we get 16. Minus 2 times 16 is minus 32. And add those, we get 0. Okay. So we start with an x to the 5. So that must mean this is going to be x to the 4, then x to the 3, x to the 2, x to the 1, and our constant. So our r of x is 0. And our q of x, remember r of x is always the thing in the very end. Q of x, so we have 1x to the 4th minus 2x cubed plus 4x squared minus 8x, and then plus 16. Okay, so 39, 51. All right, so the next bit of problems, so we want to use these for how to factor. So let's do one of these together because basically it's the same steps. It's basically what we've just been doing. Let's do, I don't know, 42. So we want to factor f of x is equal to x to the 3 plus x squared minus 13x plus 10. So the techniques to factor here, so this is always going to be the same thing. So we need to find first a 0 of this problem. And then the only way to really, because we can't factor this, usually we factor and then find the zeros. We want to go in the backwards order. So we kind of want to do some guess and check. And the way these problems are set up is we'll be able to find a 0 quite easily. So what we first want to do is we want to, so guess and check to find a 0. And the numbers that we're going to choose is going to be 0, and then we'll try plus minus 1, and then plus minus 2, and so on. So like just easy numbers to plug in. So before we continue on, let's just do that. Let's guess and check until we find a number that gives us 0. So what happens if we plug in 0? Well, f of 0, that's going to be 0 plus 0 minus 0 plus 10. This doesn't equal 0. So we got to move on to the next one. Let's try positive 1. If we plug in 1, we get 1 to the 3 plus 1 to the 2 minus 13 times 1 plus 10, which equals 12 minus 13, which equals minus 1. So that doesn't equal 0. Let's make sure everything's all looking good. So 1's not a 0. Okay, so didn't make any mistakes there. Let's move on to the next one, f of minus 1. Okay, so minus 1 to the 3, minus 1 to the 2, 13 minus 1, plus 10. So this is going to give us minus 1 plus 13. Wait a minute. Sorry, let me look at this. We made a mistake somewhere else again. Oh, I copied the problem down wrong. Which one did I copy down? Sorry, I copied this. We had to start over. I mixed 42 and 43 together. We need to start over. Let's erase all this. Sorry about that. This needed to be a 2x cubed. Minus 13x plus 10. Okay, is everything copied down correctly? That needs to be a squared. Okay, now the problem's copied down correctly. Sorry. Anyway, so the zeros to choose again. So 0 plus minus 1 plus minus 2. So let's try 0 for this one. We would get 0 plus 0 plus 0 plus 10. So again, that's not a 0. Let's try 1. So we're going to get 1 plus 2 minus 13 plus 10. And that does equal 0. Okay, so we found our 0. One of our zeros is going to be 1. And then, so once we find a 0, we're going to do synthetic division with that number, meaning that we're going to do synthetic division, and we're going to put a 1 right here because a 1 was the 0. So these are always just the sequence of steps. We find a 0, and then we use synthetic division with that number. Okay, so what's the highest power we have is an x to the 3, so we need our x to the 3 column, x to the 2, x to the 1. constant. So we have 1x to the 3, 2x squared minus 13x, and then 10. Okay, so now do synthetic division. Bring down that 1. 1 times 1 is 1. Add those, we get 3. Then do the multiplying step, 3. Add those, we get minus 10. Multiply, minus 10. And add those, we get 0. And we need to get 0 at the very end. If we don't get 0, then we made a mistake. So then what we see now is well, let's remember that equation, the P of x is d of x, q of x plus r of x. Let's fill out this equation. So what is d of x? D of x is always x minus whatever this number is. So x minus 1. What's q of x? In this problem is going to be x squared plus 3x minus 10. Remember, this is going to be our x squared now. This is our x, and this is our constant. Because it's always 1 less than what was ever up here. And then our remainder is 0. So if we fill out this equation, so what's p of x? Well, p of x, is going to be just the equation given to us. So we can write that out, p of x. All right, so filling out that equation, we have x to the 3, 2x squared, 13x plus 10 is equal to d of x, which is x minus 1, and then q of x, x squared plus 3x minus 10. So the problem asked us to factor. So far we've done one bit of factoring. We were able to factor this piece. We wanted to factor that, but now we factored into x minus 1 and that. So now let's see if we can factor any more. Well, we can't factor x minus 1 anymore, but we can factor this piece. And we don't need to do anything fancy. We can just do like the techniques we've been doing from the previous section. So this is x minus 1. And what are the numbers that multiply up to minus 5, but then multiply up to minus 10, but add up to 3? So that's going to be x plus 5, x minus 2. And so this will be our final answer. Okay, let's do one more problem together. So we're going to do one more problem together. It's basically the same thing as this one, but we're going to add one more step to it. So let's do, how about 51? So let's factor f of x is equal to x to the 3 plus 7x plus 6, and then graph. So to remember to graph these, like if we need to be able to find the zeros and then do that number line thing. So in order to find the zeros, we have to factor. So we have to do like this technique that we just did from the previous problem. So in order to factor this one, we have to guess, like what are some of our zeros? So the possible guesses that we do are always 0, plus minus 1, plus minus 2. And let's see if we can find one. So what is f of 0? F of 0 is going to be 0 plus 6, which does not equal 0. So let's move on to the next one. F of 1, that's going to be 1 plus 7 plus 6. That doesn't equal 0. So let's try f of minus 1. This is going to be minus 1 minus 7 plus 6. So unfortunately, that doesn't equal 0. Let's try 2. So that's going to be, well, 2 is not going to work either. Let's try minus 2. That's going to be, this shouldn't take this long to find a 0. I believe we made a mistake again. Sorry, I copied the problem down wrong. That's why this isn't working. This needs to be a minus sign. Start over this part again. All right, so that'll change things. F of 0, that's, well, it's still not going to work. That's going to get 0 minus 7 plus 6. I'm sorry, 0 minus 0 plus 6. That doesn't equal 0. If we plug in 1, we'll get 1 minus 7 plus 6, and that does equal 0. So we found a 0. So now in order to factor this piece, just like in the last problem, we need to use synthetic division with that number. So 1, and we plug our, so we need our x to the 3, x to the 2, x to the 1, and then the constant column. So the number in front of x to the 3 is a 1. We don't see an x squared, so we put a 0. The number in front of x is -7, and then our constant is 6. So in doing synthetic division, bring down the 1. We have 1 times 1 is 1. Add those next, we get 1. Then 1 times 1 is 1. Add those, we get -6. 1 times -6 is -6. And add those, you get 0. Okay, so here's our x squared, x constant. So what is everything? Well, our dx is always x minus whatever that number is, so x minus 1. Then our q of x, well, 1x squared plus x minus 6. It comes from these numbers and that stuff down there. The remainder is 0, which is what we needed. And then our p of x was the thing that was given to us, x to the 3 minus 7x plus 6. So filling out that equation, we get p of x is x to the 3 minus 7x plus 6 is equal to, so d of x, x minus 1, q of x, x squared plus x minus 6, and then the remainder is 0, so we don't need to do plus 0. All right, so now let's do that same thing. Can we factor this thing even further? X minus 1 just stays the same, and can we factor this? And that answer is yeah. So what numbers multiply up to -6 but add up to 3? So that's going to be x plus 3, x minus 2. So multiply up to -6 and add up to 1 in the middle. So 3 times -2 is -6, and if we add those, we get +1. All right, so we factored everything. So what do we have now? We have f of x is equal to x minus 1, x plus 3, x minus 2. But now we want to graph this. And so remember, to graph, we need to find all of our zeros. So we have x minus 1, x plus 3, x minus 2 is equal to 0. So x is equal to 1, x is equal to -3, x is equal to 2. And we put those onto a number line. And then we pick the numbers in between each of these sections. So this is the same technique from the last section that we did. So number to the left of -3 is -5. In between -3 and 1, we could choose 0. In between 1 and 2, 3 halves. And then bigger than 2, 5. And then we plug these numbers into f of x. Okay, and all we care about if it's a positive or a negative number. So if we plug in -5, so -5, plug it in here, plug it in here, and then we are going to get a negative, negative, and then a negative, so that gives us minus. If we do the same thing with 0, we would get a negative, a positive, and a negative, so that makes positive. Do that same thing with 3 halves. That'll give us a positive, positive, minus, so that gives us negative. And do that same thing with 5. We get all positives. Okay, and so now with that, we were able to make our graph. Put our zeros down here. We had -3. We had 1. Then we had 2. Okay, and we look back to our number line. We see to the left of -3, it's negative, so it goes down. In between -3 and 1 was positive, so it goes up, it comes back down. In between 1 and 2 is negative, so it goes down, comes back up. And to the right of 2 is positive, so it goes up. Okay, and so that will be the graph for this one. That's also a good place to end it. So that takes care of all the homework problems. So we'll finish up with this section tomorrow. We only got one section to do tomorrow, and then there's some review on Monday and Tuesday. And then the next test, I believe, is on Wednesday. The schedule's online. I'm pretty sure there's 2 days of review, so the next test will be on Wednesday, I think. Okay, cool. So I'll see you guys tomorrow. Thank you.